we're happy to share this success story with you today. My name is Tobias. I work as a IoT specialist at Zoi.
And yeah, welcome also from my side. My name is Sebastian Rohlf. I'm a cloud architect at Heidelberger Druckmaschinen, or in short, Heidelberg. Heidelberg is more or less a poster child of a German engineering company, and we're mainly building industrial printing machines. Heidelberg has a history of more than 170 years, so the knowledge of generations of engineers went into our products, but there's still some innovative challenges left for people like me. And today we want to share a story with you, how Heidelberg uses the cloud, together with partners like AWS and Zoi, to drive a new business model in the print media industry, and how a scalable technical foundation was the key to achieve success here. So this here is an industrial printing machine manufactured by Heidelberg. It produces high-quality print products with a volume to cover more than 2 soccer fields in just 1 hour. So in other terms, 6 large sheets of paper this dimension every second. That's, state-of-the-art precision engineering, and this results in a machine lifecycle of more than 15 years. And if you ever had the chance to see one of these during production, you should really take the chance. That's really fascinating. We also call it a Swiss clockwork in XXL. Selling these machines is a core business of Heidelberg, and we're quite good at this. So for these offset machines, we're the world market leader with a market share of more than 40%. So it sounds very good. You might ask, why do we need partners like AWS and Zoi? So let's move on to the challenges. Heidelberg has almost 10,000 employees, and we're working very hard on improving the software as well as the hardware to increase the overall productivity of our machines by 5 to 10% every year. But assuming a constant print production volume, this means a decrease of the demand for new machines, which causes a massive impact on our core business. This motivated us to think about a new, more sustainable business model where we extend the scope to the overall success of our customers. And in 2017, we started the first step with Heidelberg Equipment as a Service. In a nutshell, we deliver the equipment and the consumables to the customer, and the customer pays per outcome, a kind of pay-per-use model. Then we learned that moving from a transactional model to recurring revenue driven by machines all the changes the relationships with the customer, from a one-time transaction to an intense partnership with our customers. So this was our first step, and our customers were asking for more subscription offerings addressing the whole value chain. So we extended equipment as a service to Heidelberg subscription, where we also include software, training and consulting, and service. And the benefits for the customer is we can use the reports and data from equipment and software and deliver the consumables that are needed right in time. From the training and consulting perspective, we can detect issues related to machine operation or performance and suggest solutions in near real time via the software. Can also offer some specific consultancy, of course. From a service perspective, we can use predictive monitoring to detect issues at the machines and solve them right before they occur. So subscription is a complete and optimized service that we deliver to our customers. And each part here is optimized towards productivity and quality. And all this is driven by data. So here, software and reliable real-time data is the key to redeem the value proposition of such a business model. And let's see where we were 4 years ago when we started with this idea in terms of digitization. So this time we successfully delivered a tool set, software components to our customers that we call Connect. This is specifically made for process automation and digitization of print shops and it was already delivered to several thousand of customers. So Connect is one of the main pillars of the software development at Heidelberg, and a very important source of experience for us. To retrieve the data from the machines, we actually did IoT since 2005. And back then, no one was even talking about it as IoT. So we did it by data ingestion of the machine log files. And we had connected a lot of machines and gathered lots of data during that time already. We also ran a machine, an application that enabled our technical experts to support our customers remotely in case of problems. So it looked quite good, but it failed for us a little bit like this picture here on the left. So you can drive there, maybe it works, but if you want to add a new lane from the bottom right to the top left, maybe, then you're in trouble. So in detail, we managed data in different solutions, but the data was neither linked nor was it generally available. We also had a lot of maintenance and cost issues, so the solutions were made problem-oriented from scratch by a mix of own and bought solutions, and these were very hard to maintain and to innovate. We also had problems with data consistency, so we had created the same insights in two solutions, and the final figures did not match. So this results in a lack of trust to the figures shown. We also lacked the capability of seamless integration of all these components in the Heidelberg subscription model. And last but not least, we were missing near real-time capabilities. So the data ingestion that we use, there's the data produced and it is processed hours or days after it was produced. So it's no real time at this point. So we concluded that we cannot use or create this new business model on top of these existing solutions. So we had to think about new solutions and about a new data platform. We decided to take a step forward and build a Heidelberg cloud based on AWS. The idea was to combine all data in a single platform and build data-driven applications on top of it. After we get this understanding, there was finally the decision, make or buy. And there were a lot of intense discussions about it. Finally, we decided to make it by our own. The main argument here was the strategic importance of this data platform for our new business model. We were convinced that we have to keep the data in our own hands and that we have to guarantee the availability of the data at any time. The second argument was a matter of speed and flexibility. So we learned already that it's important to react fast on upcoming demands or feedback. And the last argument was that this gave us the option for the most flexibility of the integration of all components. And with this said, I'll hand over to Tobias, who will tell us more about the technical solutions.
Thank you. So, all right, our journey began like 4 years ago. We started to develop the concept of the platform in a response of the challenges that came with the equipment as a service sales, the increased machine sales, and a workforce that couldn't keep up with the growth. So our main focus was to support the service teams, and we focused on several key areas. Firstly, we required near real-time data processing, so we make sure that our service teams had the most up-to-date data available. Secondly, we had the requirement to collect and analyze large amounts of data, historical data, so we can identify trends and patterns and optimize our service processes. And finally, we required to establish independent product teams that are able to solve business objectives on their own and don't rely on others. And this also involves the creation of DevSec and FinOps teams. So our first steps was to get the machines connected. We did this by integrating the IoT client into the machines in the print shops, use the AWS IoT core to connect the machines via the MQTT protocol. Once you receive the data, they are transferred to the Kinesis data streams and further enhanced by Lambda functions that filter the data for the most relevant parts, which are stored in DynamoDB later. At the same time, we also created our first application that is able to retrieve the data from databases. And after a period of about 6 months, we integrated 3 field test customers into this application and started to create our first dashboard. Here you can see a screenshot of this first dashboard. There are 5 tiles. Each of it represents a customer machine. You can see the progress at what the print shop is, the speed at which the machine is running, and several other information. All this data was received with near real time. So from a state change on the machine until it reaches the dashboard was in about 2 seconds or less. And this was done with only 3 developers included. So our development phase felt pretty fast. So after this success, we started to identify our next business cases, which would make the most impact on our business, and we came up with the 2 use cases. Our first use case involved file transfer from machines. This was a significant improvement for the service technicians, as the first things they do when a problem on a customer machine arises is to get the latest log files. And in the previous solution, this could take hours or even up to days to get to this data. So to solve this problem, we developed a web application we call Remote Service Portal that allows our service technicians to retrieve and see the files available on machines. And we also integrated the file transfer handling for upload and download by using Lambda functions, S3, and DynamoDB. This also comes with the capability to queue file requests, so in case machines are offline. Our next use case is that we found out that many software and firmware related issues on the machines could be resolved through the user interface on the machine. So we thought about making this interface available in a remote desktop session. We started to look at some third-party tools, but many of them required additional software installation either on the machine or on the service technician computers. And this ultimately led to more maintenance work and software installations, and that was not what we were looking for. However, we knew that there was a VNC server already on the machines, and we found a web-based VNC client that we integrated in our remote service portal. And luckily, AWS released the secure tunneling gateway a few months earlier, and it was a perfect fit because it uses WebSocket as the protocol, and this was used by the client and the machine side. So with these changes, the service technicians felt really happy as they were able to solve problems more quickly and react to issues more fast. Here you can see the remote service portal and an interface of the file transfer, as well as a open VNC session user interface on the machine. In less than 2 years, all of our service technicians were working with the new tools. In the meantime, we kept developing this further, but these 2 really made a difference to help with the increased workload. And today, there are around 3,000 remote sessions and about 500,000 file transfers per month. So with these results, we began to work on our next digital products. We found that, it turned out that it really made sense to have the IT data platform as the basis and foundation of our digital ecosystem. It handles the basic authentication, the connectivity, the data validation and all related tasks, and also, of course, provides the data for our products. Our small independent product teams, which we developed in the beginning, along with the serverless technologies and services, helped us to focus on the business logic rather than the infrastructure, and also reduce the operational complexity and costs drastically. So we began developing our new products to help our customers and also service teams in their production processes. The remote service portal for remote desktop access, as well as near real-time monitoring of machines. Insights for analyzing historical data and getting insights into productivity performances. The maintenance manager for viewing and planning maintenance work on machines. And the Heidelberg customer portal that allows customers to sign up once and get access to all of the available products. And also with the scalability of our IoT platform and the experience we gained in the years, that allows us to develop and bring out new products to customers quickly. Let's have a look at some quick technical achievements so far. So the data platform and its first digital product was developed in about 14 months from scratch to production. Going back to one of our initial requirements, we kept providing the near real-time data processing from 2 seconds or less. And as we continue to develop and optimize our platform, we can now reliably handle 20,000 machines, sending around 35 million of telemetry events per day. And this number grows. And with this insight of the technical solution, I hand back to Sebastian.
So finally, on our journey from on-premise development to cloud technologies, there were some learnings on our way that we want to share with you. So, as you heard, we started with a small team of experienced on-premise developers, but with very little cloud experience. And in the beginning, we thought that this technical challenge might be the biggest problem. But supported by AWS with trainings and specific consultancy, and by partners like Zoi, we made it to inspire the whole team for cloud technologies. And after this initial step, this was more or less a self-amplifying process. So there's still a continuous learning, of course, but the technical challenge is no more a problem. Second part is you have to keep the company's organization in mind. For us, it was very beneficial that we could take the central decisions for the transformation within a single organizational unit of the company. And it was also very helpful that we had the full support and backing of the top management as well as the stakeholders. We have also reorganized the structure of the company and formed more or less 20 small teams on the principle that they can vertically act and take the full responsibility of a single or more cloud products. And the last part is closely related. Do not underestimate the cultural challenges that come with this transformation or adjustment. So the teams get the full responsibility for a cloud product, but they must be enabled to take this responsibility, and the management must be willing to delegate the decisions to the teams. This is really a huge step for an established organization, and still in progress, but we are on a very good way. And the last question, what's next? Encouraged by the success we had with the data platform, we continued to consolidate all digital touch points and form a digital Heidelberg ecosystem that is used by our customers and by our technical experts together. And I'm very happy that I can continue this way at Heidelberg together with partners like AWS and Zoi. Thank you for your attention.
Thank you.